All right, let's review for our final exam. The first skill we're going to review is, can we simplify radicals? So what we need is the list of perfect squares and perfect cubes. So for 12, if you look at the list, what number on the list goes into 12 evenly? And that number is 4, and then the square root of 4 is 2, and 3 is left behind and is prime. Let's try that again. Now cube root. Now you have to look on the other list, the perfect cubes. Again, you can press pause. What number goes into 24? On the list, that's 8. And then the cube root of 8 is 2. And then what's left that's prime is 3. Cube root of 54, 27 is the number that goes into it evenly. It's 27 times 2. And then the cube root of 27 is 3. And the cube root of 2 is left over. Square root, we're looking at perfect squares. What perfect square goes into 27 evenly? That's 9. And the square root of 9 is 3. And 3 is prime and left over. The cube root of negative 81. Remember that cube roots can be negative. That's going to be negative 27 times 3. And the cube root of negative 27 is negative 3, with 3 left over. Square root of 18, can you simplify that? What number can you square root that goes into 18 evenly? That's 9. That's 9 times 2. So the square root of 9 is 3. So it's 3 root 2. Can we do some algebra? When you square root 16, when you square root algebra, you take the exponent and divide it by 2. So these have to be even numbers, which they are. So divide by 2, that's 1a. Divide by 2, that's 1b. Here we're going to simplify 18. 9 times 2. X cannot be simplified, and then y squared. So the square root of 9 is 3. The square root of y squared, divide by 2, is y. And then 2x is left that I can't simplify. Cube root, same thing, but now we're dividing by 3 with algebra when it's a cube root. So negative 24 is negative 8 times 3. So the cube root of negative 8 is negative 2. The cube root of y cubed divided by 3 is y. And then 3x squared is left underneath that I can't simplify. The cube root of 81, we just did that one. That's 27 times 3. A cubed is good. Now b to the 4 we're going to break down into what number is smaller than 4 that you can divide by 3. That's 3, but we need one more b, so it adds up to 4, so they're equivalent. Now we're ready. So the cube root of 27, the cube root of a cubed, and the cube root of b cubed divide by 3. And then what I didn't cross out, 3 and b, is left underneath. Keep going. Cube root of 16, break it down. What number can you cube root that goes into 16 evenly? That's 8. 8 times 2, and then x cubed and y cubed are perfect because you can divide by 3. So the cube root of 8, the cube root of x cubed, divide by 3 and you get 1x, divide by 3 and you get 1y. So all of these we cube root. The only thing we couldn't cube root is 2, and it's left behind. 27 is 9 times 3. So the cube root of 9, or the square root of 9 is 3. The square root of x squared is just x. And then what's left over is 3y. Here, we're adding and subtracting now. These have to match. So first I'm going to simplify to see if they match. So 8 is 4 times 2, and 18 is 9 times 2. So the square root of 4 is 2 times negative 2. That's negative 4 root 2. Square root of 9, that's 3 times 2, which is 6. And now compare, see how they match? So 6 take away 4 gives me 2 root 2 as an answer. Again, I'm going to simplify first. That's 4 times 5. So the square root of 4 is 2 times negative 3. That's negative 6. And the number you don't see here in front is 1, so it's negative 6, subtract 1, so that's negative 7 root 5. Number 15, Again, simplify first. So 27 is 9 times 3. So the square root of 9 is 3 times 3 is negative 9. Now these match, so 3 take away 9 is negative 6 root 3. 20, we're going to simplify it. That's 4 times 5. 45, we're going to simplify it. That's 9 times 5. So the square root of 4, I don't have any food on my face, right? All right, the square root of 4 is 2 times 3 is 6 root 5. Square root of 9 is 3 times 2 is 6 root 5. So 6 plus 6 is 12 root 5. Turn the page. Again, you should pause and try it first. If you're going to practice for your exam, you got to practice, practice, and then press play to see if you did it right. So negative 24 is negative 8 times 3. Oops. So one thing here, the cube root of negative 8 is negative, so a negative times a negative is actually going to make this positive 2. That's a little tricky. With 3 left over, we have positive 3. And then 2 plus 3 is 5. So recognize that 2 negatives make it positive. 48, 8 times 6. So the cube root of 8 is 2. So it's 3 take away 2, which is 1 cube root of 6. None. I don't need the 1 in front. All right, now we're going to multiply. When we multiply, the index still needs to match, but what's underneath does not need to match. So we're going to go 6 times 3, and then our answer we're going to simplify. So 6 times 3 is 18. 18 is 9 times 2, and the square root of 9 gives me 3 root 2. I'm going to multiply this together. The square root of 36 is just 6, and then multiply it, and you get negative 18. Again, we're going to multiply. Sometimes when you multiply, your answer doesn't simplify. Like 10, there's no number that goes into 10 to simplify, so that's it. Negative 3 root 10. Here we got 4 root 10. Again, there's nothing I can do. And recognize what's in front, multiply, so 1 times 4 and 2 times 5. And that's it. Nothing else simplifies. Sometimes you have to distribute. So that's going to give me root 50 and 5 root 5. Recognize that a square root and a square root, they multiply. But a square root and a number that's not a square root do not. They just go beside each other. Now, root 50 is 25 times 2. So the square root of 25 is 5 root 2 plus 5 root 5. So because this is a 2, even though it's hard to see, and that's 5, they're unlike, so that's the final answer. 24, again, you should press pause and try. This is 2 root 3, and this is 5 root 18. 18 can be broken down as 9 times 2. So the square root of 9 is 3, times 5 is 15, root 2. Done. Number 25, root 3 and root 2 is root 6. Root 3 and root 6 together is root 18. Root 18 is 9 times 2. So we have root 6, we have the square root of 9, and 2 is left over. These are unlike, so you can't add them together. This one, number 26, is a FOIL. So we're going to draw a box. That's root 2 and 4 and root 2 and 1. And we're going to multiply it out. So this is the square root of 4. This is 4 root 2, 1 root 2, and then 4. Now, the square root of 4 is really just 2. So it's 2 plus 4, which is 6, and 1 plus 4, which is 5 root 2. Done. Let's try that again. Draw a box. So we have root 2 and minus 3, negative root 2 and negative 3. We're going to multiply this out. We're going to FOIL it. So this is negative root 4. And negative is positive root 2, 3 root 2. That's negative 3 root 2. And that's positive 9. So recognize these. Did I set up right? All right, these are going to cross out. This is just negative 2. So I'm going to write it as negative 2 plus 9, so the answer is 7. The square roots cross out. 28. Root 3 minus 3 squared. We just repeat root 3 minus 3 twice. We're going to multiply this. That's root 9, negative 3 root 3, negative 3 root 3, and that's positive 9. These do not cross out. They're the same, so it's negative 6. Anyways, this is the square root of 9, which is 3. So it's 3 plus 9, which is 12. And negative 3 and negative 3 do not cross out. That's negative 6. And you have your answer. Dividing. So, what is 6 divided by 2? This is 1/2, by the way. You don't see it, but that's 1/2. And then 6 divided by 2 is 3. So it's root 3. Same, there's a 3. That's in the numerator. That's different. 2 goes into 18 9 times. So it becomes this. And then the square root of 1 and the square root of 9. And then if I divide this out, the answer is just 1. Here, 3 divided by 3, and then 6 divided by 3 is 2, and you have your answer. Here we have 3. Again, 6 divided by 3 is root 2. On the page. Can we simplify this? Go ahead, press pause and see if you can simplify these. 4 divided by 2. 8 divided by 2. Now the square root of 4 is 2. So that's 2 times 2, so that's 4. Let's try again. 4 divided by 4, that's 1. 3 goes into 48 16 times, so that's 1/4. The square root of 1, square root of 16. Again, press pause and try it. Here, nothing simplifies, so this is requiring us to rationalize the denominator. So that's 2 root 2 and 3 root 4. So the square root of 4 is 2. Before I multiply, I recognize the 2's cross out, so that leaves me with root 2 over 3, and that's it. Here again, 3 goes into 6 evenly, so that's 1/3. So both are square roots. 1/3, 1/2. So 2 times the square root of 1, that's just 2. And then I'm going to multiply by root 2. So that gives me 2 root 2 over root 4, or 2 root 2 over 2, cross out, and the answer is just root 2. More steps than it looked like. All right, let's try this again. Nothing to simplify here, so I'm going to multiply by root 3. And then just recognize that 3 goes into 9 3 times, and you have your answer. Again, press pause and try your best. Multiply by root 2, that's root 6 over 2. Nothing I can do after that. All right, what happens if you have a binomial in the denominator? You need to write a binomial with an opposite sign. So that's 4 plus root 3. We're going to draw a box. 4 plus root 3 and 4 minus root 3. We're going to multiply this out. So 4 and negative 4, they cross out. This is just negative 3, so it's 16 take away 3. And then the numerator, 4 times 4 and 4 times root 3. Done. Again, I need to do a binomial with the opposite sign. So instead of subtracting, we're adding top and bottom. Again, we're going to draw a box to FOIL out the denominator. And then multiply. Press pause and try. So a negative times a negative, positive 16. A negative times a negative, positive 4 root 2. A negative times here is negative 4 root 2. And then that's negative root 4. So these cross out. Square root of 4 is 2. So 16 take away 2 is 14. And then the numerator is negative 16 and positive 4 root 2. recognize that you could divide the top and bottom by 2, and you get negative 8 2 root 2 over 7. All right, what does a fractional exponent mean? And it means a radical. So the denominator tells you the root and the numerator the power. Again, the denominator tells you the root and the numerator the power. The denominator tells you the root and the numerator the power. The denominator tells you the root, the numerator the power. All right, how about the other direction? Here, this we write as a fraction where the denominator and the power you don't see is 1. Here 10, the fraction, the root is the denominator, the power is the numerator. Again, the denominator is the power. I don't see the power, that's 1 when you don't see it. Same thing here. I don't see it, 1 is the power that you don't see. Could you simplify this? All right, so we haven't talked about fourth roots much. I'm going to do it's not on the exam a fourth root, but we'll talk about it. What number 4 times itself is 81? That number is 3, and then 3 times 3 times 3 is 27. We're going to let it go. And this one, we're not going to let go. What does this mean? The denominator means square root, and then the numerator is the power. So in other words, what is the square root of 64? And then 8 to the power of 1 is just 8. That one, yes. Same thing here. What does the denominator mean? Square root to the power of 3. So what is the square root of 36? To the power of 3. 6 times 6 times 6. I'll help you. 216. Cube root. It's going to be a big number to the 5. So the cube root of 27 is 3, and then 3 to the 5 is 3 times 3 times 3 times 3. It's like 343. Double check my work. See if it's true. All right, let's solve an equation. The numbers on the exam are small. All right, let's solve an equation. To undo a square root, the power undoes this, and that's 4m take away 3 equals 9. Add 3, and then divide by 4. Now the thing is, we need to check to make sure our solution is correct. So you go back to the beginning and you plug in 3. And see if left side equals right side. So you take this answer, plug it in, let's see if it works. 4 times 3 is 12. 12 take away 3 is 9. And the square root of 9, it does work, and so this is a good answer. If it didn't work, you'd cross it out, no solution. All right, number 54, subtract 1. That's 6, square both sides. That's 6 take away 3p equals 36. Then we're going to solve it. Subtract 6, and then divide by negative 3. Now, that gives me the answer negative 10. So then I'm going to go back here. I want to see if it works. So 1 plus 6 take away 3 times negative 10 equals 7. So negative 3 and negative 10, positive 30. The square root of 36 is 6, so that works. So negative 10 is a good answer. All right, turn the page. When a square root equals another square root, we just square both sides, and you're left with 9 subtract b equals b subtract 3, and then we're going to solve it. So I'm going to add b to both sides. So that's 1 plus 1, that's 2b. I'm going to add 3 to both sides. 9 plus 3 is 12, and then divide by 2. Now again, I need to check to make sure that answer works. So I got to plug 6 in. In particular, what I'm looking for is I can't have a negative number under a square root sign. So when I go 9 take away 6, they're both equivalent, but they're positive 3, and that's what I'm looking for. So this is the answer. Number 56. Square both sides. We got 3v take away 13, 11 take away v. Bring this together, so I'm going to add v, add 13, and then divide. Now, once you have your answer, go back in and see if it works. That's a 3. In particular, I'm looking for, is this a positive value under the square root sign? And it is. So both sides equal each other, and it's positive 5, so that's a good answer. Number 57, again, we're going to undo the square root by squaring both sides. That gives me x squared equals 42 minus x. I'm going to add x. I'm going to add x and subtract 42, and then I'm going to factor it. The two numbers that multiply to negative 42 and add to 1, and those two numbers are 7 and negative 6. And then when you solve this, so each factor equal to 0, one answer is negative 7, and then the other answer is 6. We got to make sure both work. So if I start with negative 7, it does not work. And the reason I know it does not work is because the square root of a number can never equal a negative number. So that one does not work, and I'm going to cross out. So whatever this is, the square root of this will not be negative 7. The other one is positive 6. So when I plug that in, does it work? And it does. So 42 take away 6 is 36, and the square root of 36, it does work. So what do we call this solution here? It's called extraneous, the one that didn't work, and this one does work. Number 58. To the power of 2, square both sides. Make it equal to 0. So I'm going to add b. I'm going to subtract 20, the opposite, and then I'm going to factor this. So negative 20 and 1. What are the two numbers that multiply to negative 20 and add to 1? And then those are your factors. And then each factor equal to 0 and solve it. So I'm going to subtract 5 and I'm going to add 4. So one answer I know is not going to work. So when I plug in negative 5, the square root of a number can never equal negative 5. So we know this one is extraneous. This one, we need to see if it works. If I plug in 4, does it work? And it does. So make sure that you do the work first and then watch the video and see which one should cross out and which one stays. All right, two more and then we're going to graph, right? All right, undo the square root by squaring. And then I need to make it equal to 0. So can you make this equal to 0? So I'm going to go subtract 14x and add 40. So the two numbers that multiply to 40 and add to negative 14, that's negative 10 and negative 4. Those are not my solutions. Those are my factors. So what solution comes from here? Negative 10, add 10. Same one, add 4. So my answers are positive 10 and positive 4. Let's see if they work. So if I plug in 10, does it work? So 14 times 10 is 140. Subtract it to 100. Is the square root of 110? Yes. So that one works. The second one is the square root of, with 4. 14 times 4 is 56. That's the square root of 16. Yep, that one works too. The square root of 16 is 4. So both answers work in this case. Sometimes both will work. Sometimes one will work. And sometimes both won't work. All right, last one like this. Solve this one. Square both sides. That's 6v equals v squared. And then make it equal to 0 by subtracting 6v. I'm going to factor out a v. Again, you should press pause and try it. And then those are my two answers, 0 and 6. So 0 I try out, 0 works. And then 6 I try out, and 6 works. So both of these work. So 0 and 6 are good. There are no extraneous solutions for this one. All right, that was solving equations. Last one's graphing. Can you graph a square root? Can you graph a cube root? This has to do with understanding a, h, and k. So a in this case is 3. H is opposite day, it's -6, and K is -3. Then I write down 3 points. So I'm going to write down 0, 0, 1, 1, and 4, 2 for a square root. The H changes the X coordinate. So I'm going to subtract 6. So to each one I'm going to subtract 6. To the Y coordinate I'm going to multiply times 3 and then subtract 3. So 0 times 3 is 0, and then take away 3. 1 times 3 is 3, take away 3. And then 2 times 3 is 6, take away 3. So those are the points. So -6, -3, -5 and 0, and -2 and 3. Then we're going to draw a curve going up to the right. Don't start this curve below that point. It starts at that point and then curves up to the right. The domain starts with the H value, which is -6 to infinity. The range, that's the K value, that goes -3 to infinity. And then the end behavior. Even though it doesn't say so, we need to know it. The right end behavior goes up, and the left end behavior goes to the point, which is -6 and -3. All right, let's try again. Graph another square root, AHK. Again, you should press pause and try your best, and then look at the answer, and then correct it and press pause again. So A is -3, H is 4, and K is 2. We're going to change these points again, 0, 0, 1, 1, 4, 2. So the H changes the X coordinate, so we're going to add 4. We're going to multiply and add 2. So 0 times -3 is 0, and add 2. The first point will always be HK for a square root. All right, 1 times -3 plus 2. And then 2 times -3 is -6 plus 2. And you have your points. So 4, 2. 5, -1. And then 8 and -4. And then draw your curve. So again, the point, what I'm looking for, the domain and range. So the domain again comes from the H, that's 4 to infinity. The range goes to the bottom is -infinity up to 2, a little different. And then the end behavior, the right end is going down because of the reflection, because A is negative. And the second is HK. All right, press pause and try to graph 63. It's the only way you're going to look at it. You have to try it first. So A is -2, H is -4, and K is 5. The points are 0, 0, 1, 1, 4, 2. To the X, we're going to subtract 4. And to the Y, we're going to multiply and then add 5. So that's HK. This is going to be 3, and this is going to be 1. So -4, 5, -3, 3, and 0, 1. And then we'll curve. The domain goes from -4 to infinity. The range, again, because A is negative, it's -infinity up to 5. And then the end behavior, the right end is going down, and the left is the point, HK. So X is going to -5, and f at x is going to 5. All right. A is 2, H is -1, and K is 2. And then write down your points, 0, 0, 1, 1, 4, 2. Try to change them. Press pause. Can you do it first? So the first one is -1, 2. The next one is going to be 0 and 4. So again, 1 take away 1 is 0. 1 times 2, add 2 is 4. 4 subtract 1 is 3. And 2 times 2 is 4 plus 2 is 6. So -1, 2, 0, 4, and 3, 6. The domain goes from -1 to infinity. The range goes from 2 to infinity. Notice it's going up. If there's a reflection, then we flip the range around. And the end behavior. So the right end is going up, and the left is HK. All right, last one is, can you graph a cube root? And then we're done. So 3 left. Again, A is 2, H is 4, and K is 3. Change the points. Now for this one, we have 0, 0, 1, 1, but not 4, 2. We have -1, -1. So a cube root can be negative. And then the first one is going to be HK, 4, 3. The next one we're going to multiply and then add. So first of all, we're going to add 4. And then we're going to go 1 times 2, add 3. The next one, -1 plus 4. Then we're going to multiply. That's -2 plus 3 is 1. So we're going to put down 4, 3, 5, 5, and 3, 1. And it curves this way, and it curves that way. Looks kind of like an S. The domain and the range are all real numbers. That doesn't change. And then the end behavior. So the right end goes up, and the left end goes down. All right, 2 left. You should press pause and try them. 66. A is 2, H is -3, K is -2. Write down the points that we're going to use. Press pause and try it first. The first one, 0, 0, is going to be HK, -3, -2. The next one, we're going to subtract 3, and we're going to multiply and subtract 2. Again, we're going to subtract 3. We're going to multiply and subtract 2. So we have -3, 2, -3, -2, -2, 0, and -4, -4. And we're going to curve this. Make like your S-like pattern. The domain and the range never change. All real numbers from -infinity to infinity. And the end behavior. The right end goes up and the left end goes down. All right, we're almost there. Last one. All right, try it. Press pause. Can you write down what A, H, and K equal on your own? What are the 3 points we're going to change and put on our graph? The first point will be HK. The next point, we're going to subtract 1, and we're going to multiply and add 4. Again, subtract 1, and we're going to multiply. That's -2 plus 4. We're going to put those points on our graph. And then we curve it. There's our curve for a cube root. The domain is all real numbers. The range is all real numbers. And the end behavior. The right end goes up and the left end goes down. And that's it. All right, press pause if you need to. Mr. G Math over and out. All right, good luck on your exam. I'm really proud of you that you did all the questions in this packet.